Hello, ladies and gentlemen. My name is Erik Roelos. I work at CITO, and I'll be your presenter in this session called In Search of Task Features that Predict Psychometric Quality of Reading Comprehension Test Items. I would also like to mention my two colleagues, Laura and Karen, who were co-researchers in this study. The purpose of this study is to investigate the role of item features related to item difficulty and item discrimination. I also look into the role of features in representing construct-relevant skills and non-focal skills. The context is Dutch exams for mother tongue reading comprehension in vocational education. So let me tell you about reading comprehension as a context. Imagine this very short text. Peter fell off the stairs in his office. The surgeon said that he would not be able to play soccer for 6 weeks. The mental account of what happened may have looked like this. Peter fell off the stairs, was brought to the hospital, probably by an ambulance. And after some treatment, the surgeon said that he would not be able to play soccer for 6 weeks. Now, what are the processes of text comprehension? Suppose that this is a text. Comprehension starts with decoding letters and words. During reading, we collect separate pieces of information, the so-called micropropositions. These micropropositions are organized into a text model, which represents the literal meaning of the text. In our case, Peter, he fell off the stairs and the surgeon told him that he could not play soccer for 6 weeks. The next level is forming a situation model, a conceptual model that is enriched by your background knowledge around a topic. In this case, I filled in the ambulance. It was not mentioned in the text, but you can infer from what we know about these accidents, so that Peter probably will be brought to the hospital by an ambulance. The final level of cognitive process is creating socio-communicative meaning. The text may have been written for a certain communicative purpose, such as evoking feelings of pity for Peter, or to inform other people who can visit him at the hospital. In reading comprehension, there's a large possible universe of text and reading tasks that all require different types of situation models. And all these processes to arrive at meaning, the construction of the situation model. These can be a lot. Models can be about how to build a cupboard, about the water cycle, and of course, in our case, about what Peter went through. Now, if we look at reading comprehension tests from an evidence-centered design approach, we can distinguish between focal skills which are important for comprehension and non-focal skills which may be necessary to arrive at an answer for an item. If we use the evidence-centered design model of item construction, you start with the student model. In the student model, the target comprehension skill, as I discussed briefly before, are specified. In order to measure those comprehension skills, we need a task model in which items or reading tasks are specified. We need tasks that have features that can be mapped directly on these comprehension skills, such as the type of text, the genre, the type of mental activity that you'd like to elicit in the tasks. How good the task and items map on the student model is evaluated through the evidence model. How difficult are the items? Do the items form a scale? Psychometric measures like p-value and discrimination index tell us something about whether the item at hand captures important comprehensive skills. In our study, we draw these features from literature study. These can be features intrinsically related to reading comprehension processes. If we can demonstrate that these intrinsic features explain differences in difficulty and item discrimination, that is proof of validity. But in many cases, items also require non-focal skills or access skills, and other than comprehension per se. And these skills can be considered extraneous. For instance, dealing with item presentation can add to task difficulty, which would not be present in real-life tasks for reading. Comprehension may ask for mathematical skills, such as making calculations. All in all, there can be features that are not really directly about reading comprehension, but they are more or less non-focal or access skills. We address the following research questions. To what extent do item features for reading comprehension predict item difficulty, item discrimination? To what extent are these features intrinsic and extraneous to the target skill? Now here are some results. In this table, we see the prediction of p-values through regression analysis. And we'll see different types of features that contributed to the item difficulty. First, there's a text feature, the lexical density, the ratio of unique words. The higher that ratio, the more difficult the associated items were. Second, the most powerful task feature was the number of inferences to be drawn in order to arrive at a correct answer. We see a large regression coefficient. An access skill feature was the topical knowledge of skills that increased difficulty. For example, knowledge of mathematics. And finally, the higher the number of plausible distractors, the more difficult the item gets. The regression model accounted for 52% of the variance in p-values. Examples. First, an item that relates to inferences. This is definitely a task feature intrinsic to reading comprehension. First, we see there's a question about a text. According to Laura, what are the characteristics of a dream job? The first suggested characteristic is good salary. Well, there seems to be no proof in the text for this. The second, time flies by, is described in the text as a characteristic of a dream job. Third, sufficient career opportunity is not mentioned in the text. Fourth, enough breaks. There was even proof of contrary in the text. All of these statements needed some form of inference to be drawn by the student. Another example, this relates to an access skill, working with graphs and proportions. The text was about spending money on different things, such as clothing. The items is about the graph. The graph below belongs to the text, but a caption is missing. Which caption matches this graph best? And in turn, it turns out that the percentage of budget for entertainment should be the caption of this graph. In order to arrive at that option, you need to use the information about percentages in the text and transcode that into the graph and find a fitting caption. So there is some mathematical work at hand here. Now look at the prediction of item discrimination value. The first predictor pertains to the text topic. There were different topics that were associated with items that were better or worse in discrimination. We found, for instance, that items from texts about traffic and transportation discriminated better than items from other topics. 3 specifically mentioned target skills from the Dutch test matrix appeared in the regression equation. First, making connections between text parts. If items addressed that skill, they had worse item discrimination. Second, connecting textual information with general knowledge. When items required this skill, discrimination increased. Third, when an item required the students to construct socio-communicative meaning, item discrimination tended to be worse. We found out that that had something to do with the way the item stem for this skill was formulated. Finally, a task presentation feature appeared. When the key represented the fully correct and complete response, we see better discrimination. All in all, the model accounted for 29% of explained variance. Now let me finish this presentation by drawing some perspectives. Our long-term purpose is to develop a systematic form of item construction arriving at relevant building blocks for valid test items, according to the evidence-centered design method. And we'd like to broaden the scope of assessing reading comprehension and arrive at a wider range of tasks than just seek and destroy false options. Thank you very much for listening to this presentation.